Hello students, so today we'll be discussing the questions from the exercises of chapter 1. Okay, so here are the first question. The first question, you can see there is a reaction given and there are 4 statements that which, and what is the question, that which of the statements here are incorrect. Okay, so look at the reaction first and then look at the first statement. What is it? That lead is getting reduced. Okay, so if you look at the reaction, you see that in the reactant side we have PbO. Okay, so PbO means lead oxide. Yes, and if you see at the reactant side there is only Pb. Okay, that means lead in its solid form. So from this, what you can tell? You can say that lead oxide is losing one oxygen atom. So that means you can say lead oxide is getting reduced, not lead is getting reduced. Okay, so first statement, that is A, is incorrect. If you look at the second statement, that is carbon dioxide is getting oxidized, so it is also wrong. Why wrong? Because if you look at the reaction in the reactant side, you see we have carbon. Yes, and if you look at the product side, you will say carbon dioxide. Now you see that carbon is gaining oxygen. Yes, that means 2 oxygen atoms is gained by carbon. Okay, so you can say carbon is getting oxidized but not carbon dioxide is getting oxidized. Okay, so second statement is also wrong. Now the third statement, C, carbon is getting oxidized, this is correct. And the fourth statement, lead oxide is getting reduced, this is also correct. Okay, so your answer will be option 1, A and B. The second question is very easy. So there is a reaction where iron oxide is reacting with aluminium to give aluminium oxide and iron. Okay, so here what is the meaning? That there is a metal compound which is iron oxide and we have an other metal, that is aluminium, which is attacking this compound to form aluminium oxide and iron. That is, aluminium, which is more reactive, is displacing iron to form a new compound. So this is a displacement reaction. Next, question number 3. What happens when dilute hydrochloric acid is added to iron fillings? So iron fillings means we have metallic iron. Okay, and it is added to dilute hydrochloric acid. Now if you look at the reactivity series, you will see that the reactivity of iron is higher than reactivity of hydrogen. So therefore iron will replace the hydrogen from hydrochloric acid to form iron chloride. Okay, FeCl2 and hydrogen gas. Okay, so this is a decomposition reaction, and due to the decomposition reaction between iron and hydrogen chloride, you will find the new products are iron chloride, that is FeCl2, and hydrogen gas. Okay, so now question number 4. What is a balanced chemical equation? You all know what is a balanced chemical equation. If the number of atoms of each element in the reactant side and product side is equal, and if the physical states are mentioned, then we can say that is a balanced chemical equation. Okay, why should we balance a chemical equation? We should balance a chemical equation because the mass of the reactant should be equal to mass of the product. Okay, why? Because we know that mass can never be created, can never be destroyed. So mass of the reactant should be equal to mass of the product. And when mass of the reactant will be equal to mass of the product? When number of atoms of each element in the reactant is equal to the number of atom of each element in the product side. Okay, so to make this equal, we have to balance a chemical equation. Okay, so this is a paragraph that is already present under the topic 1.12 balanced chemical equation, and I have highlighted the answer. So from this you can write your own answers. Okay, but this thing should be present in it. Next, this is a very common exam question, that is translate the statement into chemical equation. Okay, So that means we have there is a chemical reaction going on, and they have written it, and now we have to just write it in the form of chemical equation. So hydrogen gas is combines with nitrogen to form ammonia. So simple, hydrogen gas is reacting with nitrogen and we are getting ammonia. So we have to know the formula of hydrogen, formula of nitrogen and ammonia, and then balance them. Okay, and hydrogen, nitrogen and ammonia, all of these three will exist in gaseous state. Okay, second option B, hydrogen sulfide gas burns in air to give water and sulfur dioxide. So whenever you will see that burns in air, that means oxygen is added. Okay, so hydrogen sulfide gas, when it will burn in air, oxygen will add to it and it will form water, which will be in liquid state, and sulfur dioxide, which is also a gas. Okay, and then you have to balance it. Now see, barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate. So barium chloride formula we can write, aluminum sulfate formula we can write, and after reaction we will see there is a double displacement reaction, and due to which you will see aluminum chloride is formed and barium sulfate as a precipitate, it will be in its solid form, and since it is a precipitate, we are giving a downwards arrow. Okay, so now D, potassium metal reacts with water to give potassium hydroxide and hydrogen gas. So formula of potassium you know, formula of water you know, and potassium hydroxide is KOH, because valency of potassium is 1, valency of hydroxide ion is 1, therefore you will get the formula as KOH and hydrogen gas, and then you have to simply balance it. Okay, so very easy questions. Now question number 6. So you have to simply balance the equation which is given. Okay, so you can easily balance it. So first one I am explaining for you. So nitric acid is reacting with calcium hydroxide to get calcium nitrate and water. Okay, so if you look at the reactant side, the number of hydrogen is 3, 1 from nitric acid and 2 from calcium hydroxide, and the number of hydrogen in product side is 2. Okay, only 2 hydrogen from water. So to balance this number of hydrogen in reactant side and in product side, you have to make the number of hydrogen in reactant and product side equal. Okay, and how will you do it? By simply balancing it. If you put 2 over 2 before nitric acid, now you get the number of hydrogen in the reactant side equal to 4, and if you put 2 before water, you will get number of hydrogen in the product side is also equal to 4. Okay, so similarly you can balance all the other elements. Okay, so these are nothing but you have to simply balance them. Number 7, again you have to convert the name of the chemical compounds into their respective formula, and then you have to balance them. Okay, and when balancing chemical equation, please try to mention the physical state also. Okay, so it is much more helpful. Okay, so if you can, please mention the physical state while balancing a chemical equation. Okay, so these are the answers I have given. Simply you have to balance this. Okay, nothing much to explain. Simply you have to balance the chemical equation after writing the chemical formula of each of the compound. Again, here also we have to balance the chemical equation and we have to identify the type of reaction. The first is potassium bromide is reacting with barium iodide to give potassium iodide and barium bromide. So you see that potassium and barium is exchanging their base. So earlier in the reactant side we have potassium bromide, in the product side now we have potassium iodide, and earlier in the reactant side we have barium iodide, now we have barium bromide. So that means there is an exchange of ion. So this is a double displacement reaction. Okay, and we can balance it. Similarly, here you see zinc carbonate it is giving zinc oxide and carbon dioxide. That means we have already discussed that if a single product is giving two or more than two products, then that is a decomposition reaction. Okay, look at option C. Here two reactants is giving only one product. So if you recall our classes, you will see that if two or more than two reactants are giving a single product, then it is a combination reaction. Okay, now combination and decomposition reaction are just reverse of each other, opposite of each other. Okay, now D, magnesium and hydrochloric acid. We are getting magnesium chloride and hydrogen gas. Okay, so this is a displacement reaction because magnesium, which is more reactive than hydrogen, is displacing hydrogen from hydrogen chloride to form magnesium chloride. Okay, so there is a displacement reaction in which magnesium, which is more reactive, is displacing the hydrogen. Okay. Number 9, very simple. What do you mean by exothermic and endothermic reaction? Give example. So reaction in which energy is released along with the formation of product are known as exothermic reaction. Means any reaction in which you see energy in the form of heat or light is produced, then you can say that is an exothermic reaction. Okay, so I have taken here the example of burning of natural gas. So natural gas, that is methane, CH4, is reacting, is burning. So while burning, always oxygen is added, and then we are getting carbon dioxide and water. So this is an example of exothermic reaction. Again, what is endothermic reaction? Endothermic reaction are those reactions in which energy is absorbed by the reaction. Okay, so or we can also say that energy is supplied to the reaction, because for the reaction to take place, you have to supply energy in the form of light, or in the form of heat, or in the form of electricity. Okay, and the example can be, you can write any of the decomposition reaction. All decomposition reaction are examples of endothermic reaction. Okay, so I have taken here the example of decomposition of ferrous sulfate to form ferrous oxide, sulfur dioxide, and sulfur trioxide. Question number 10. Why is respiration considered as an exothermic reaction? Because what is respiration? That respiration includes digestion as well as our breathing process. That is, we are breathing in oxygen, and how that oxygen is helping us to digest our food. All this together, it includes respiration. Okay, so during digestion, what happens? Whatever food we eat, that is broken down into different simple products like glucose. Okay, so mostly the food that we eat contains glucose, carbohydrates, and these carbohydrates is broken down into glucose. Okay, and when we breathe in, we breathe oxygen. Yes, we take oxygen, and this oxygen will react with the glucose which is produced after digestion of food, and this reaction produces energy. Okay, so if you want, you can look at the chemical equation also that I have mentioned here, that the glucose which is obtained after breaking down the carbohydrates present in the food, that glucose can react with the oxygen which we are inhaling, and then they will form carbon dioxide, water, and most importantly energy. So that means respiration is the process by which energy is produced from glucose and oxygen. Okay, so since in this reaction energy is produced, we can say that respiration is an exothermic reaction. Okay, so I have written down the answer here along with the chemical equation. You can just have a look. Okay, number 11. Why are decomposition reactions called opposite of combination reaction? Because in decomposition we will see a single reactant is breaking down to give two or more products. Okay, but in combination reaction you see a single product is formed by two or more reactants. So in one we are seeing two reactants are adding to form one product, and in one we are seeing that one product is breaking to form two reactants. So therefore decomposition reaction is the reverse of combination reaction or opposite of combination reaction. Write one equation each for decomposition reaction where energy is supplied in the form of heat, light or electricity. That you can do. We have already discussed question number 11. The answer of this question number 12, this answer of this question is simply you have to write the examples, and that is already given in the book. You can write it. Okay. For electricity you can write electrolysis of water. For light you can write decomposition of silver chloride. For heat you can write any of the reaction including decomposition of ferrous sulfate, decomposition of calcium carbonate, decomposition of lead nitrate. Any one of these three equations you can write for energy supplied as heat. Okay. Now question number 13. What is the difference between displacement and double displacement reaction? Write equations for this reaction. So simply you can write the definition that in displacement reaction, more reactive metal, it displaces the less reactive metal from its compound, whereas in the displacement reaction there is an exchange of ions. Okay, so the ions of one reactant goes to the ions of the other reactant. Okay, so that is double displacement reaction. So simply if you know the definition, you will write the answer of this question, and you have to write the equation for both these reactions that you can do. Okay, so you have to write one example or one equation for displacement reaction and one equation for double displacement reaction. Okay, so very simple. Now question number 14. In refining of silver, recovery of silver from silver nitrate can be done by displacement with copper metal. So there will be a displacement reaction between silver nitrate and copper metal. Okay, so you have to write the reaction. So displacement is between silver nitrate and copper, and since copper is more reactive than silver, copper will displace the silver and you will form copper nitrate and silver metal. Okay, simple. So you have to understand the question. There is recovery of silver, that is we will get silver from silver nitrate. And how we will get silver from silver nitrate? By a reaction, displacement reaction with copper metal. That is, if you have to write the reaction, you have to understand that the reaction is taking place between silver nitrate and copper. And what reaction? Displacement reaction. So there you can see from the reactivity series, copper is more reactive than silver. So silver will get as a solid metal and copper will form a complex with the nitrate. Okay. What do you mean by precipitation reaction? Explain by giving example. So any reaction that produces precipitate is a precipitation reaction. Okay, simple. An example already present in your book, where sodium sulfate is reacting with barium chloride to give barium sulfate and sodium chloride. Okay, again you can also write the example where potassium chloride is reacting with silver nitrate to give silver chloride and potassium nitrate. So that is also an example of precipitation reaction where you will get white precipitate of silver chloride. Okay. Next, 16. Explain the following oxidation and reduction in terms of gain or loss of oxygen. That is, what is oxidation in terms of oxygen? It is gain of oxygen. Okay. And what is reduction? It is loss of oxygen. So in terms of oxygen, oxidation is gain of oxygen and reduction is loss of oxygen. But in terms of, if the question is what is oxidation and reduction in terms of hydrogen, so loss of hydrogen is oxidation and gain of hydrogen is reduction. You have to be very clear on this. Okay. So question number 17. A shiny brown colored element on heating in air becomes black. So this is the example that we have already discussed while discussing the redox reaction. That is, copper powder is brown in color or copper metal is brown in color. Whenever you heat it in presence of oxygen, you will see a black colored powder forming over it. Okay, so that is copper oxide. So this is the reaction that is already discussed. Now 18. Why do we apply paint on iron particles? Because applying paint prevents rusting of iron. Okay, so how it prevents rusting? Because for rusting to occur, the most important condition is that water and oxygen togetherly at the same time must come in contact with iron. So if you will apply a paint on the surface of iron particle, then what happens? Iron surface cannot directly come in contact with water and air. Instead of the iron surface, the paint will come in contact with water and air. So therefore, rusting cannot occur. Okay. Oil and fat containing food items are flushed with nitrogen. Why? Oil and fat containing food items are flushed with nitrogen because oil and food items undergoes oxidation. Okay. Oil and fats in food item undergo oxidation, which leads to rancidity. Okay. So if you will put nitrogen in it, okay, if you will flush nitrogen in those containers which contain oil and fat containing food, this nitrogen will prevent the oxygen from coming in contact with these food items. That is why these oil and fats undergo oxidation, because when they come in contact with the oxygen in air, they slowly undergoes oxidation. But if you put nitrogen, so there the amount of oxygen will be very low. Yes, so therefore you will see that the oxygen which is present in the air, so there is more number of oxygen atoms, okay, or molecule. In air we have more number of oxygen molecules, but when you will flush it through nitrogen, okay, you will use nitrogen, then the number of oxygen inside those food containing packets or container will be very low. Number of oxygen will be very low. So therefore these oil and fats cannot easily come in contact with the oxygen, and therefore oxidation process will be very slow, or even sometimes it will not occur. Okay, so that answer is that oil and fat containing food items are flushed with nitrogen to prevent rancidity or oxidation of oil and fats in the food items by preventing oxygen and coming in direct contact of these food items. Okay, so explain corrosion and rancidity. So that you all know what is corrosion, what is rancidity. We have already discussed in our last class of this chapter 1. Okay, so I think that is all of our today's class. Okay, so the questions in the exercises are very simple, but still I have given you the answers. Again, I also want to tell you that in your board exams very less questions you will get directly from the exercises. Okay, the questions are generally conceptual and related to the concepts which are present in the chapter. Okay, so you will not get much of direct questions from the exercises. Okay, so please be ready for it. Okay, and some of such questions I will be discussing in my channel also. So please subscribe the channel so that you can get notification about them. Okay, so thank you.